2035. I put this up, and I really want to say, you know, you see all this stuff about game change, and the game basically has already changed. You know, you look at Shell, one of the biggest oil companies in the world. The first time in its history, they're going to produce more natural gas than oil. That's amazing. And then, you know, here's another article, and they talk about Rex Tillerson at ExxonMobil, and he says, you know what, right now we produce as much natural gas as we do oil. And he thinks the fracking party has just begun. So, you know, my point, here we are in this revolution, you know, people are calling it a game changer, but my thought is, if, you know, here we are in the energy industry, and if you're not somehow involved in this, you know, I think the game's over. So, I mean, I think everybody in the energy industry, you know, should have some play in this game if they want to make money in the energy industry. All right, next chart. So you say, like, why natural gas? What's the big deal about it? Well, if you say, you take a barrel of oil, it's 42 gallons, and you say, how much energy do I get out of that barrel of oil? Well, a barrel of oil, you get 6 million BTUs. BTUs are British thermal units, a unit of energy. But that barrel of oil costs 98 bucks, you know, about $100. And then you go, okay, well, if I want to get that same 6 million BTUs out of natural gas, what does that cost? You go, it's right now it's about $2 per million BTU. And so the cost is like 12 bucks. It's like such a disparity, it's like unbelievable. So that's the excitement, and we'll talk about that a little bit. And you know, it's cleaner. You know, you look at a natural gas molecule, you have one carbon, a couple hydrogens, burns, you get one carbon, and you look at a gasoline molecule, you know, it's a much more complex molecule. When it burns, you have all these things that partially burn, unburned hydrocarbons, a bunch more pollution. So not only is it cheaper, it's cleaner. And then when you get natural gas out of the ground, you don't have to send it somewhere and, you know, put it through towers and pull out the important stuff. It basically uses, it comes out of the ground. So there's so much value with natural gas. But the bottom line is we have more than anybody else. So, next slide. Well, the other part is, you know, businesses are starting to see that too. It's not just people directly in the energy industry. You know, there's an announcement put out just a little over a month ago that General Electric and Chesapeake are partnering to build a natural gas fueling infrastructure. You know, here we have, you know, natural gas in the United States at $2. If you go to Europe, natural gas is selling for maybe 13, 14 bucks. You know, what a disparity. And, you know, it's really, really cheap here. And, you know, we had a mild winter, they had a little bit of overproduction. It's going to come back. I mean, prices are going to go back up. But they want to, you know, increase the adoption of natural gas as a transportation fuel. I mean, we have so much of it. It burns cleaner. It's cheaper. It seems like a no-brainer. So, but they say the biggest hurdle is, you know, if somebody converts their cars to natural gas, where are they going to refuel it? So, starting in the fall, GE plans to provide 250 modular compressed natural gas fueling stations to try to get this thing kickstarted. You got other people trying to do that. You've probably seen Warren Buffett's out there, you know, putting together things, and trying to think of the other gentleman's name. T. Boone Pickens doing the same thing. All right, next chart. So they say, okay, all this is great news. What's the problem? So, you know, here's really it. Environmental concerns are threatening the revolution. You got people coming out and saying fracking is having a lot of environmental problems. A Duke study came out that said, you know, they tested well water around fracking sites and found gas in the wells. And then New York State issued a moratorium on hydrofracking. And just recently, if you follow the news, not like Vermont's any big, you know, state with a lot of shale oil, but they just issued a ban on fracking in Vermont just in the last few days, and I think it's kind of symbolic, but you know, it's fracking is kind of getting a bad name. And even so, like I put another magazine, just came out, like it comes across my desk, and has a picture of CEO of Southwest Energy, and they're a big shale producer out in Fayetteville Shale in Arkansas, and basically saying, you know what, we're getting killed, and so we need to put together some kind of new social contract and let people know that we're going to do all this responsibly. And a lot of the other larger producers are joining in, and I think with that and our technology to be able to you know, solve some of these environmental issues is going to be instrumental. Next chart. So here's what we believe. We believe that 100% monitoring of hydrofracking can alleviate the concerns. But the problem is gas price is kind of low, the margins it's kind of tight, and the cost of the equipment to monitor it costs as much as to drill the wells, so nobody's doing it. And basically on the order of a couple percent are monitoring, and the majority are being done blind. We believe that regulators will possibly require monitoring, but also we talked to some of these, and talk a little bit more about this later, some of these producers, they're willing to do it. They said, we'll monitor 100%, we just got to get the cost of the equipment down so that it is affordable. And you know, that's where we come in. So, you know, at over 20,000 wells per year, you know, drilled and fracked, you know, this is where, you know, we think our sweet spot is. I mean, right now it's a couple percent are monitored. If it gets into the 50 to 100%, and we're the key technology for this, which we believe we will be, you know, this is a big business for us. You know, I put this in because, you know, this is what potentially may drive some of these producers to do things without being regulated. Is they're trying to put out this regulation that says if there's some pollutants, gas, or something found in an oil in somebody's water well, rather than saying, okay, we need to go figure it out, that if that water well is in a certain distance and they're saying 2,500 feet from some gas well, you're presumed liable. You know, and a lot of people are upset about this. Is like, wait a minute, what happened to this innocent until proven guilty? So that's starting to scare a lot of the producers. So, you know, I think there's added incentive for them to want to change and monitor. Next chart. So, you know, here I say that our thoughts are that you should monitor, but, you know, there's this Secretary of Energy Advisory Board. They're basically saying the same thing. You know, and I pulled out, you know, they had a subcommittee that put out a bunch of recommendations. This is Secretary Chu's advisory board set up by Barack Obama, and came out with on the order of a dozen recommendations. And, you know, here are some of them. Microseismic surveys should be carried out to assure that hydraulic fracture growth is limited to producing formations. That's exactly what we're saying. So it's like mimicking that. You know, one, you don't want to frack outside the pay zone because you're wasting fluid, but two, if you get it outside the pay zone and it can go up into the aquifers, that's not good. But if you're not monitoring, you have no idea. And then the other part is field studies on leakage from shale gas wells. This is called gas migration, which is the other thing we monitor for. So two of the key things that we've been talking about came out in this report. You know, industry experts also agree. You know, we're working pretty closely with a company called FTS, Fractech Services was their old name, but now they're called FTS International, one of the largest multi-stage unconventional service companies. Basically, they frack on the order of 10 to 20,000 wells a year in the United States, and they're looking to expand internationally. But, you know, they want to be a good steward of the environment, but the technology right now that says just too much. We can't, you know, we can't make it's not profitable for us. But so we're working really closely with them to develop a custom monitoring solution for them, and they want to be the first company out there to offer 100% monitoring of all their frac jobs. So I think this is huge. And I like that their little logo says, "Don't just work with the latest technology, create it." And when you meet with these guys, you know, they're really, really forward-looking. You know, if you look in the history of the company, they started 10 years ago, a couple guys with a couple trucks, and built it up to a couple $billion-dollar company in less than 10 years. So very impressive. Next chart. You know, then there's also a little more on experts agreeing is that, you know, headline is real-time microseismic monitoring can prevent the problems, and this is AAPG, American Association of Petroleum Geophysicists, you know, came out with a report, and it said microseismic monitoring, you know, basically saying if you see some geohazard you don't want to go to, meaning an aquifer, it's a fault, and you start seeing fractures occurring in there as you're fracking, you could shut it down and just stop that stage and move to the next. And you know, I was talking to some, there's a guy here, Luis San Miguel from Sigma 3, heavily involved in this business. You know, he was telling me that, you know, let's say they frack, they're going in, they're going to frack like 10 stages. You know, typically only 3 or 4 of them are the real producers, and the other ones are sort of wasted. But you can't tell unless you're monitoring it. So, you know, it's just another important thing about monitoring, which we bring to the table. Next. So talk about, you know, all this hydrofrac monitoring, what actually is it? So what happens is you have a well that goes down to where the shale is. It's typically down a mile or so. The shale bed's typically a couple hundred feet thick. And so where they used to try to go in straight down and try to fracture along a vertical, you didn't get enough oil, enough gas or oil. So now they go out a mile along the shale bed, and then they fracture, and you get a lot more release. And once you frack it, it'll produce for on the order of 20 to 30 years. But how to monitor is you put sensors down adjacent wells, and sensors say like ours. And as they frack a stage, you know, like there's different stages, 1, 2, 3, and they block off the area, pressurize it, and on the order like 15,000 pounds of fluid, and it cracks the rock. As it cracks, you see all these fracture events, these little dots tell you where these fractures are occurring. And typically once they'll do one stage and the next, and they color code them so you can see each stage as you go down, like first, second, third, fourth. But what it really allows you to do is see where they're occurring and know that, okay, I frack where I want, I don't want to frack outside, I don't want to waste fluid, or if nothing's happening, you just move on, right? There may be some thief zone that's pulling the frack fluid and you're just wasting it. So in order to be most efficient, you know, you really do have to monitor. And